Welcome to solverfy.
In this particular situation, uh, let us assume the dimension of the water tank is this weight is W and this weight is A. Now, we are trying to find the pressure exerted on this section of the tank. The height of the hatch is H, and total height from the water surface is D. So if we consider a depth of X, then the pressure at this location is given by P equals P naught plus X rho of water times G. So the force on that area is given by the differential force on this little section is given by dF equals P naught plus X rho G times dx. So the total force will be given by P naught plus X rho G integration of dx, and the integration limit will be from this point to that point. So this much is given by d minus h to h, which will be P naught x minus half rho g x squared h g minus h the first term will give us P naught times h minus g minus h. The upper limit of integration is d, so that comes out to be d minus h, so P naught h minus half rho g squared minus g minus h square. Putting the values in, we get force equals there is a plus sign over here. So the total force will be given by half rho g we have to, for calculating the force, we have to use our W over here as well. So W will stay constant outside. Now notice that this part of the force is balanced on either side because the atmosphere pushes it from the outside as well. So the excess force is half rho g W d square minus d minus h square equals half times 1000 times 9.8 times W equals 2, and the inside part becomes plus 2dh, so that 2 times d equals 2 times h equals 1 minus h squared, which is 1 square. Calculating this, we get the force to be 2.94 times 10 to the 4 Newton. Now, when you want to calculate torque, torque is given by force times displacement. In this particular case, we have to start from using the differential torque, which is the force on the differential section at a height of h, at a height of x, times the distance from the hinge, which is the distance over here to there, which is given by x minus d minus h. X minus d plus h. Now we will have to write the force again. The force is given by the, so we are talking about the differential force in the section, and we can just use this formula again. So that will be rho g w x times x minus d plus h, and the height of the section is dx. So we have to find torque, which is rho g w x squared minus d minus h x dx, and we have to integrate it from over the same limit from d minus h to h. And the integration limit stays as d to T minus H. So that comes out to be rho GW d cubed minus d minus h cubed divided by 3 minus d minus h times 2 down there. So d squared minus d minus h squared. Simplifying this comes out to be rho g w over 6 3 d h square minus h cube. And putting the values in, the torque will come out to be 1.63 times 10 to the 4 Newton per meter. We have used rho equals 1000, G equals 9.8, W equals 2, and H equals 1. So that is the answer.